we have our circuit diagram for our system, and we have the Arduino, our latches, and 8x8 LED matrix units. I'll just show you basically the different parts. This is our Arduino, and our Arduino Uno, and I've actually used the tape to prevent bridge when we get to put it on a metallic surface. So I'll use the bridge. Also, this is our IC 74HC574. HC there stands for high speed CMOS, and it's actually what we're going to be using for our row latch. So we have two of them. We're going to be using for row latch, and we have also a column latch. That's our 74HC574. It's actually a 20-pin dual inline package IC, and that's actually what we're going to be using. Then also we have our panel, which we have actually extended by adding jumpers to the cathodes, and which are shown earlier, and the anodes. So I'll just go ahead and explain the different parts of our circuit. So the Arduino, actually the wiring is very straightforward. It uses we're going to be implementing this on a breadboard, and we're going to be using jumpers to connect our Arduino to the 74HC574, the latches, and the Arduino 8 bits from the Arduino will be pin 0 through pin 7 is actually going to be connected to the IC, and you can see that here that there's actually a parallel connection, meaning that they are going to be receiving the same data, but they will be receiving different clockings, which the Arduino would decide. So based on what the Arduino decides and programming, it gets to decide whether it's a row that is turned on and allows data to flow to the matrix panel, or the column that is actually latched, whose data is latched to the columns. So the pins 0 through pin 7 is actually connected physically to IC. Pins 2 through pin 9 is actually our data in, and pins 12 through to pin 19 is actually our data out, and pin 11 is our clock in, and is actually used to clock the data from the input to the output. So any data that is here will get to be once it receives a high, a clock pulse off and on, or on and off, it allows the data to be clocked to the other side, and that's how the LED gets to the 8x8 matrix LED gets to be turned on. And also you can see also that I have pin 1 is actually your enable, and it's actually connected permanently to ground. Pin 10 is actually your ground, your VSS or ground. Pin 20 is VCC, and it's permanently connected to 5 volts high. And so these two ICs actually will be responsible for allowing your data information to be displayed on the 8x8 LED matrix. So this, like I explained earlier, is actually our row latch, and this is our column latch. And the Arduino gets to clock the respective latch, the latch that needs to be clocked, that allows data to be clocked to the other side, to the matrix panel. And that's just basically the design. So we're going to be implementing this on a breadboard, and I'm just going to show you and walk you through the different steps.